All right, if my video max is 15 minutes, so if I ever get cut off, just go to the next video. I'll continue. I'll try and like wrap them up so there's like a good place to stop, but sometimes I get a little carried away and excited with the calculus and I forget to look at the clock and just cuts off. So that last one cut off. So this is where about where we were. And what I was saying is these should be um, this region right here. So let's say root 2 plus root 2 is just root 2 over 2 plus root 2 over 2 is just root 2. So root 2 minus 1 should be this region right here. Okay, and then this, if we were right with our symmetry guess, this should also equal root 2 minus 1. So let's find out. I know it looks negative, so let's see what happens there. 1 and then minus, and this is root 2 over 2 plus root 2 over 2 is 2 root 2 over 2, which is just root 2. So then if I distribute the negative, so I still have the first integral, and then if I distribute the negative, I get minus 1 and a plus root 2, right? So if I distribute that negative, this becomes negative, this becomes positive, so I get a root 2 and a minus 1 and a plus. And you can see they were indeed symmetric. I get the same thing. So I end up with a final answer of 2 root 2 minus 2. All right. Okay. Next example. Let's go to a new page. All right, this is a new type of problem that you haven't really dealt with. You'll notice these functions look weird. They're input y, output x. So we got to change our thing. We're going to do a lot of these coming up. The next section, what we do is we take this region, like we're going to take a region, I don't know, let's do an easy one. This is y equals x squared. And we're going to rotate it around an axis, right? And what happens when you rotate, you get a three-dimensional thing. So you get like this rotation here, and you get this like big like cone looking figure. We're going to figure out how to find the volume of that, kind of building on the area between curves thing. And it's pretty cool. It's a really cool technique that we can find volumes which are three-dimensional just using like two-dimensional calculus, okay? So when we do those, we want to be able to do not just functions of x like we've always done in the past, but functions of y. What does that mean? What's a function of y? So let's graph this thing. So I know how to graph y equals x squared minus 2. It's this. Okay, note input x, output y. Big Y is up, little y is down. This is the kind of the inverse of that. Input y, output x. Big, so my outputs are x, so that's like left, right. So bigger outputs are to the right now. That's like big x values. And smaller outputs are to the left, and those are little x values. All right, so if you were to graph this, you could do everything we did like a long time ago. You say input y. What happens if I plug in -1? Plug in y equals -1. What's the x value there? -1 squared is 1 minus 2 is -1. So you get -1. What happens if I input y equals 1? 1 squared minus 2 is -1. So a y input of 1, that's here, gets an x output of -1. It's all backwards. How about if I plug in y0? y0 goes here, output x is -2. Okay, and then you can see what happens. You get a parabola, but it opens to the right. All right, and then y equals x, well, x equals y, I should say, is the same thing as x equals y. And they would intersect here, and we're asked to find this area. All right, let's find that area. So now we're going to integrate over y. Right, everything's changed here. We're going to integrate over y, so our bound's got to be y, our function's got to be y. My first question to you is, what function goes on top, the y squared minus 2 or the y? Which one's bigger? So you got to stop thinking in terms of up and down and thinking in terms of right to left. Which function is always further to the right? Well, that's your line y equals x, right? So, I'm sorry, x equals y, I should say. So this is the bigger function, this guy, right? Because it's further, you got to really think left to right now, right? You got to kind of turn, what I do is turn my head and I say, which one's on top? Well, if I turn my head to the right, I can see like the lines on top. And then what's on bottom, the quadratic. Okay, and we integrate over y. And then I need values of y here. So what's my lowest y value? Well, that looks to be, I'm sorry, that's an x value. What's my lowest input value y? That should be here, right? So now we're back to up and down. All right, outputs are left, right. Inputs, y, are up and down. So that looks like it's -1. And I'm going to guess this is 2, but I got to back that up. We got to make sure that's right. That's just based on my very poor graph. So what I want to do is make sure that those bounds are correct. So how do we do that before? We set y squared minus 2 equal to y, and we solve. We did with x, but in this case we do it with y. And I can solve that pretty quickly. And I get y equals -1 and y equals 2, and my guess turned out to be right. Okay, so now I'm sure that this will give me the area. So let's see what we get. So I want to integrate from -1 to 2, y minus y squared minus 2 dy, and that should give me y squared over 2 minus y cubed over 3 minus 2y evaluated from -1 to 2. Okay, so what I do next, I plug in 2, I plug in -1, and that's my area. Oh, I just caught a mistake there. If you distribute that, you get plus 2y. Okay, so the upper bound is 2 squared over 2 minus 2 cubed over 3 plus 2 times 2. Let's clean that up. That's 4 over 2, that's 2, minus 8/3, plus 4, which if I add all that up, that should be 10/3. Okay, minus the lower bound, plug in -1, -1 squared over 2, minus -1 cubed over 3, so that's -1/3, so I'm going to do plus 1/3, minus 2, and that should all be 1/3 plus 1/2 minus 2 should be -7/6. Okay, so that's my upper bound, that's my lower bound, and there's a minus in between, so I'm going 10/3 minus -7/6, and that should give me 10/3 plus 7/6, so that's 26 plus 7/6, which should give me 27/6, which I can reduce, right? I can take 3 into both of those, 9/2. 9/2. That is the exact area of that weird looking region. Okay, Calc 2, get used to it. Look at this mess. Right? I actually redid this video because I made a mistake somewhere. I can't remember where. I don't know where it was, but you gotta be real careful. Like I realized as I was going, I got too small of a number. I had some sense to what that area should be. I think I got like 3/2 or something. I knew it had to be bigger than that, so I know I messed up. So I had to go back and do it and be a little more careful. So I advise you to do the same. This is Calc 2. This is a lot going on. I mean, look at this last problem, that great trig problem that we did. Let's see, I got one more for you. How about this one? Okay, so let's get a new page here. One more problem, area between curves. So I did this one intentionally. This one's going to look funny to you, but let's think about it. Okay, so we're back to y as a function of x, and I want the area between two curves. And I graphed them for you because this one might be a little tricky to graph. Y equals 2 is easy to graph. That's the blue line. And then I want this area here. So I can pretty quickly figure out that the regions, if I'm given the graph, I don't have to set them equal to one another. That'd be kind of a hassle to set this equal to this. It caused me to do some work. But I don't have to do that because the graph is given. So I can just set up my integral directly. So I'm going to integrate function of x, y equals function of x, from -1 to 1. Bigger function, in this case on top, 4 over 1 plus x squared. Smaller function, 2 dx. Okay, so then you integrate and you say, well, look at this thing. In Calc 1, if I had a rational function, I would do this. U equals 1 plus x squared. Du equals 2x dx. And then I'd sub out dx, and I get, what do I get? I get du over 2x. Right? And if you try that, it's not going to work. Right? You're going to just looking at this guy, 4 over u and then du would be, dx would be du over 2x. And this never really happened to us in Calc 1 because it always worked out nicely when we were doing those logarithmic integration ones. And it doesn't go away, so I can't use this method. And I did this intentionally because we just did this in our first video when we looked at 311, it should be. I might have called it 310, but it's 311. Either way, it's inverse trig functions. So this is actually an arctan function. So I go back to I say, well, wait a minute, that's a rational function. Let's go to my little list here of integrals. Oh boy, look at this list right here. You see that? X, if I have a dx over x squared plus a squared, and that's just how they write dx. I put my dx at the bottom, and there's a 4 there. So let's see if we can match that. It's just the arctan of x over a. All right, let's see if we can apply that. We learned the derivative, but we haven't integrated. But it's not that bad. So if I want to integrate 4, I'll just pour the 4 out. How about that? All right, constant multiple rule. And then I have 1 over 1 plus x squared. And you know that here's what we just learned. The derivative of the arctangent of x is 1 over 1 plus x squared. I don't even need the chain rule for this one. I don't even need a u sub. So that means the antiderivative of 1 plus x squared, oh, look at that nice circle, is the arctangent of x. So that's going to be 4 arctan x. Okay, so back to my area. The area is given by -1 to 1, 4 over 1 plus x squared, minus 2 equals 4 times the arctan of x times the arctan of x. And then the antiderivative of 2, that one's easy, minus 2x, evaluated from -1 to 1. Oh, good. We get calc or trig practice. 4 times the arctan of 1 minus 4 times the arctan of -1 minus, that's the upper guy, minus, and then this one's easy, 2 times 1 minus 2 times -1. Okay? And that should give me what? Well, we could have factored out the 4 originally. What's the arctan of 1? The tan of pi over 4 is 1. What's the arctan of -1? Well, that's got to be negative pi over 4. And then this is 2 plus 2, that's 4. Right, minus, you gotta be real careful with your signs. 2 plus 2 is 4, and that's my answer. But I can clean that up a little bit. That's 4 times pi over 2. Pi over 4 plus pi over 4 is pi over 2 minus 4. So that's equal to 2 pi minus 4. 2 pi minus 4.